and I'm juggling the microphone in one hand and a small clicker in the other hand and a laser. Being carefully not to point at you with a laser here. And thank you for being here as well. The last presentation of the day, almost closing the event here. Short presentation of me. My name is Jacob, and I'm an engineer here in a sales suit. Although I will not be selling you anything today, I will talk a little about our food retail and data. I come from Danfoss, which is a big pile of engineers, a lot of technicians, a big company. We've been in the business for 90 years, a lot of inventions. We're not only doing refrigerations here, we're also doing power solutions with hydraulics, not hydronics, hydraulic solutions for trucks, for tractors, construction industry. We also have a drives division where we are doing gears and managing motors and engines for instance, elevators, so they go up and down nicely and not just start and stop. So a lot of different areas, and what is common for all these areas and hardware that has been invented and then we are producing today is that it also can produce a lot of data. And this is where I come from. It is the digital division. We are 200 people on top of all the hardware and the clever people here that actually collects data from various solutions and use that for monitoring and operating and optimizing the different existing hardware solutions. I will talk to you a little about food retail today, what we do, and what we will be doing tomorrow, which is the next couple of years, and then also how we see a little into the future, which I call the crystal ball of this. And in the end, there will be a chance for questions, or we can take them afterwards, or we have a booth in Hall 7. We have 15 to 20 minutes for this. So I will jump directly into this one. A lot of information here. I'll start at the bottom of this one, which is not today, it's also today, but this was also yesterday. This is how a lot of the supermarkets that we work will operate today. Of course, they have some case controllers to control all the cases, pack controllers to control the compressors, etc. Then we also can control the rest of the HVAC and the lighting there's in the supermarkets. And then the new kid on the block, as I call it, the smart energy. Here is some energy meters pictured on this slide, but this is actually a lot more than that. That is also the ability to manage, not only seeing how much you're spending, but also to manage the consumption, and also to work with the energy providers that are providing the energy, for instance, electricity, if they have some demand response requests that we can fulfill. This is an area in high development for us, especially in the US market, where many of the utility providers are saying, okay, but if you as a supermarket will lower your energy consumption in certain time periods of the day, then we will actually give you money, which can be an additional revenue stream, not only bringing down the CO2 and the energy consumption, but also be a revenue stream for the supermarkets. This is on the individual level. This is running a lot of stores. Most of the stores in the world running this way, autonomous, and works quite well. Then it's usually also connected to some sort of controller that controls the different areas. In Danfoss, we call it the system manager. It could be something different from other vendors as well, which actually controls things on a store level, this one. And this is the today, and this is where I come from. The digital solution on top of all this, we call it Alsense in Danfoss. which is used for collecting the data from all the different devices here, and actually giving the ability to manage the devices and manage the stores. So what we do with this, we divide the solution into 4 areas here, 4 hubs as we call them. What you see far on the left side is the alarm hub. This captures the alarms from the system. Is something going wrong here? Is it running optimally? It can be on various levels and severities, these alarms. But common for all of them is that we have somebody sitting and looking. It could be somebody from the supermarket. It can be from a service provider. It can even be a managed service from Danfoss looking at these alarms and saying, now we need to call somebody to do something. Or we can triage them a little more technically and see, do we need to send somebody to the supermarket? Many places today, it just sounds an alarm. Somebody goes to the supermarket. It costs a lot of money to send these people out. The triaging saying, we can wait with this, or this will resolve itself, or maybe we just need to call somebody and say, close the door on some of the fridges here, or send it as a message to their phone in the different stations in the supermarkets. So it's just resolved immediately. Then we have the temperature part. This is where we collect information about temperature in the various assets in the supermarket. This is used for various reasons, both for making sure that we are not having things running in a too cold environment, which costs extra money for cooling down. On the other hand, it shouldn't be too hot, because then we risk the food safety. So it should be within the right band here on the temperatures. Furthermore, this is also for authorities. There is reporting requirements of reporting what are the temperatures in the various assets. So we can make sure that things are running after the book here. The middle part, the technicians, those are the ones that actually are being sent out to the stores and fixing everything here. I call them the clever people, because this is where you really need to know something about what you are gorging or repairing out in the stores here and making it run. Then we have this is we call it the maintenance manager, but this is a remote again, where they actually look at the data, and when they also have the ability to look at all the details on how the stores is running from a configuration point of view. This is where they look at the set points that are set and how they operate the compressors, and should it run for a long time or short time, or is it running for a short time or long time, and then set those settings back to the supermarkets again. What we have here is also the ability to register changes that happens to the system. For many of the stores, they're just running, and that is fine. But if you sit as in a central level, you can see if something was changed in the store from yesterday to today. And then you can say, somebody has changed those set points. Why is that? And you can either approve it or reject it, so it goes back to normal operations, or you can even challenge the technicians that have done it and say, call him up and say, why did you change this in this supermarket? And he says, that's because we're running some tests. And then we say, okay, that's fine, and then we acknowledge that. So we can actually keep track of how the individual supermarkets are running. And if you're having a whole chain, you can even have kind of templates on how you run your supermarkets, and then push these as templates for running a supermarket optimally that you have set, and then see if there's any deviations from that. This is from the service hub perspective. And then the energy perspective is, how much energy are we consuming in the individual stores? This is both, from on a case level, it can be from the lighting, it can be from the HVAC, and everything in the store. And more importantly, in this area, we can also a baseline what they're using, so we know what this store usually spends, and also adjust it for the temperature that we have, the ambient temperatures, so we can predict what should the store spend tomorrow and the day after tomorrow, and then we can monitor if this differs from that, and then we can send people out to fix it or something, or at least we have an ability to say, oh, this is running more than we expected, and there can be various reasons for that. So this is a little about how we top up the hardware today with digital solutions that keeps evolving with new features all the time. But this is just a small part of the bigger ecosystems around the store. So we are, with this, maybe up in the corner for monitoring and management. And then we have built a store also. Danfoss built a store, we call it a smart store, where we actually now also experimenting with everything around it here. So this is where we see the future is coming, or at least tomorrow, because we have it already. So for all the other things here around this, we have put in, starting over there, with the solar panels on top, where we can get energy from the solar panels to help us, reduce the energy from the electricity from the grid here. We can control the lighting here. We have cold and heat storage tanks. This is also for reusing some of the heat that we extract out of the cooling into the store for convenience here, and also for the buildings around the store. They get the heat from this one. We have batteries. We have batteries outside this store, so we can actually store, if we have excess electricity or energy, we can store it in those batteries. We are, and this is I put it in green here, and this is not today, but we built the infrastructure for it. It says tomorrow, actually also to integrate to the car charging. Because why not, if we have excess energy here and electricity, why not offer it to the customers outside in the parking lot when they have the electrical cars, or the other way around? So the cars is charging at zero cost in the night, comes to the store. There are already cars today that can deliver electricity out of the cars and deliver it to the store, and then we can give them a rebate in the store for giving us electricity to run the store. And then we have the heating of the stores. We have floor heating in stores. We also have put in this is kind of a ground loop outside, but it's in the parking lot, so we can use, if we have excess energy in the wintertime, we can just de-ice the whole parking lot with that. This is the ground loop heat pump. We have connections to the external heating grid, because we get energy from utility companies into the store, or maybe I should say we can get energy. Because what we actually found out now is that we are producing excess energy from this store, so we have reversed it. So we are delivering to the external grid instead and getting money for that. And this is also where we kind of correlate these things. So sometimes when the electricity is cheap, then we and the energy grid is paying more for the heating, then we can decide to produce even more heating in our cooling system, from the cooling system, and put it into the grid, and that's optimizing the whole ecosystem here. That's also part of the smart grid to deliver electricity back. But this is actually where we are taking it, as I would say, to the next level. We have built, these are many of the components that everybody is running today. The challenge is actually to being able to run them together in the network, and that is what's going to take place within the coming years. I call it the future. We're kind of ticking them off one by one. On this side, this is some of the insights that we get from what we already have. The solution, the Alsense solution, is running now in 16,000 stores worldwide, and an install base of these system managers in the store, 75,000, with a lot of alarms. And that actually gives us a lot of insights how to run these stores optimally, which can be used in the solution also for other chains and other stores on this one. And then we're not finished with this, so this kind of keeps evolving. And I say, 5 years from now, more will be integrated in this. The times run quicker than you would think. Jumping into the future, even more here. This is just giving some credit to IoT analytics. More generically, they made an analysis of setting up twins, and this is where you actually duplicate what we have now done in the store with all the different small connections that you saw before. This is taking this to the next level, so you actually simulate everything you have in real life just in the computers. And this will evolve. This will involve, it's already begun, but in the next 5 or even 10 years, you will have totally built twins around these things, so you can do the emulations or the analysis before you build it in the stores. So instead of running around and testing, let's do this and connect this to that and see how that works, we just simulate it here. So this is where we see it going up to this one. The big usage, 28% for the simulation of new systems, and also for predicting what will happen if we make these changes. What would happen if we make a small change to the way we run the compressors, or if we take into consideration that the sun will be shining? Can we lower then the use of energy for the HVAC, or can we produce more electricity from the solar panels and sell that back to the electricity companies, etc.? What is also, when we get all this data and into the twins here, we would also be able to make virtual sensors. So today we have in the cases, we can measure, yes, the temperature in the inlet here and the temperature in the outlet here, and this is probably what the temperature is in the case, and this is also what we report in the hazard reports. But what if we could also estimate what is the temperature inside the food? So taking that to the next level, so we know what is the density of the food, and what is the how long have it been at, let's say 2 degrees. So maybe it's fine if it's 2 degrees inside the food, and then the refrigerator is 8 degrees for 5 hours. It may not ruin the food because of the density, and that we can monitor with virtual sensors. Other sensors could be for leak detection. Today you have, you really gauge how much refrigerant there is in the system. But what if we just measure how much energy we put into the system? What is the output of the system, and maybe other sources of information that we have the pressure in the system, and then say, okay, now we know that it's running at 90% instead of the 100%. And then we decide also from the other data here, say, do we need to do something about it? Or is it okay to run this way for the next 30 days where we have a technician out there anyway? Even though we know it costs more electricity, but that's no problem because we also predict that the next month electricity is free. So there's various use for this. In the future, there will also be more collaboration with the hyperscalers. And when it says hyperscalers here, it's like the big tech companies like Microsoft, Google, Amazon, the ones that actually are able to process the data. They don't know a lot about, they know nothing about refrigeration or anything, and the operating technology that is needed there. But they are important partners for actually processing the data in the big data centers for us in these collaborations. And then I put on this one, digital twins across systems. Because one thing I also believe in, that in the future we will see a lot more standardization in these areas. Today, Danfoss we produce our own equipment and devices here, and everybody else produces their own equipment when you walk around here. In the future, they will just connect. Just like we have with the USB, you put in the mouse or you put in something in the printer, anything in the computer, that will also be the future here and standardized. So we can just put in all the things you saw in the bigger grid before. You can put that into the systems, and then you can actually do the simulations across systems and across manufacturers within the next 10 years. All right. Very quickly on this one, where would that take us from today to the future here? The alarm hub, temp hub, that will be standardized. That will be mostly managed by the computers. They will search for the alarms. They will evaluate what to be done and send out the information to whoever needs it. And the storm manager can just only react to the alarms that he needs. Things that needs to go to the authorities, that goes automatically. The guys in the middle, then we cannot, they need still to be there. They will never be replaced. You cannot send out the computers or anything to fix the store. The maintenance manager and in the operations, they would be able to simulate a lot of things and optimize the stores, and they will get good insights for that from the system and saying, should we do this, should we not do this, or even automate it. So you will not be in a situation where you say, is this running too cold or is this running too hot? Should we turn a button here? No, the system will do that itself. So it is exactly where it should be. And for the from the energy manager, same. They would not just be looking at the data they get from the store here. They would look at it in a larger perspective and also from the total grid that we had before. And eventually, I truly believe that we will get to a situation where we will become both net zero and CO2 neutral. Thank you for staying with me for 20 minutes.